goal is to do this actually. What's the limit as x approaches 0? We can't use a 0 in there. So we want to eliminate that x, that h. So we want to factor it out of there. So what we do is we substitute in these guys. We want to reduce it out of there. If you get to this point, after you do all of this, subtract your function. If you get to this point and you can't eliminate a term that doesn't contain an h, so we need to be able to factor that out, then something went wrong. The first place to look is right here at this negative one, which means you might not have distributed the negative. You might have just subtracted the first term. Another place is right here. This is not x squared plus h squared. This is, the x squared will cancel out. The h squared, you'll be stuck. But this is a FOIL process. It's x plus h times x plus h. So at this point, we can cancel out a negative x squared, a positive x squared, a negative 3, a positive 3, a negative 2x, a positive 2x. We're left with terms that contain h. Then we can factor and reduce. Thus, we've eliminated your denominator. Good? Okay. Same thing with this next one. I like to do this. I like to put my x right on top. It's easier for me to visualize that wherever my x is, now is going to become x plus h. I'm going to plug my x plus h in there. Just because you substitute it in, make sure you follow order of operations. Again, we're watching the limit as h approaches 0. When you do this, this gets done first. Order of operations has parentheses exponents. Do this first, then distribute your negative 3. This part stays, okay? Keep it in parentheses. At this point, you should be able to reduce anything that doesn't have an h. It should cancel itself out. Bring down what's left. Doesn't matter how bad it looks, as long as they both contain h, you're good. Factor out the h and cancel out your h. Factors. And all I need for you to do is leave it like that. How are we with this, okay? Questions on this at all? You have basically 3 types of domain restrictions. One, I have a fraction. My denominator cannot be 0. So we're going to set your denominator to 0 and solve. For instance, I want to know what x values can I use in my domain. My numerator is full, but my denominator, whoops, I cannot not let my denominator be equal to 0. So I take this out and I set this equal to 0. I factor, whatever it requires me to do. And I say when x is 2, when x is 1, I have a problem. It will make my denominator be 0. So we take a look at your domain and we remove it out of your domain. These are the 2 values that I cannot use. I can use all of this in between, all of this. So my domain that I'm allowed to use, my restricted domain, will be negative infinity to 1, jump over the 1, between 1 and 2, jump over the 2, and from 2 to infinity. And that's how I write my domain. Okay? Second, that bothers us is under a radical. For instance, I can't, in my real number system, take a square root of a negative number. Any odd roots have no restriction. A cube root has no restriction. I can take a cube root of a negative number. Any even root, they all have the same restriction as a square root does. So I cannot take a negative number. So therefore, on my number line, negative numbers are here, to the left of my 0. Can I use 0? Can I take the square root of 0? So from here on out, I'm okay. So I take this out, and I set it greater than or equal to 0. This will automatically find your restricted domain, because you're setting this up. So my domain would therefore be -1 to infinity. Good? My third restriction kind of combines the both of these. A radical in the denominator of a fraction. So if I put this in the denominator, I can still use most of that domain, but if I stick a -1 in here, what happens to my denominator now? It becomes a 0, and I can't, my extra restriction is no 0. So I take this out, and I just set it greater than 0. So it's a soft bracket at the -1. There's my domain. Remember your 3 domain restrictions? These are important. Because when I ask you for a restricted domain, you have to go by these 3 rules. Now, we have another little situation under a radical. Sometimes we have a quadratic under a radical. Such as this. Now, that's an x squared minus 4. If I graph this guy, let me just graph this and see what this looks like. Oh, luckily it's there. Look what my graph looks like. Can you tell what my domain is right from looking? Is it all real numbers? No, because somewhere in the middle here, I get a lot of errors. Look where my errors are. Somewhere in there. It looks like from -1 to 1. However, it's a little bit further than that. I'm okay to use -2, but not anything to the right of that. I'm okay to use 2, but not to the left of that. So let's see if we can find this domain. We're going to keep that in mind, and we're going to use your rules. We're going to set this greater than 0. Let's not make this a fraction. Let's just make this a regular, since I didn't graph it with a fraction. So we're going to say x squared minus 4 greater than or equal to 0. You're going to set this equal to 0 and find your factors. These are your critical values. You're going to put it on your number line. And we can use the 2 and the -2. They had values. And we're going to test where everything is. And we're going to separate these into 3 sections. I want when it's greater than or equal to 0, so I want when it's positive. Now, an easy way is to look at your graph or look at your table. Let me pull up my table. When my table is to the left of -2, my values are positive. When my table is between 0 and -2 and 2, I can't use. When my table is to the right of 2, my values are positive. Remember, sometimes it dips into the negative, right? And we can't use the negative. This time I only want the positives. So therefore, I want this and this. So my domain here would be -infinity to -2 or 2 to infinity. A quadratic works a little bit different when it's under a radical. You have to follow your rules of the quadratic. You have to find the critical values and test them. Okay? And even if you imagine this is a parabola, if the parabola fit in here, wouldn't it be positive over here, negative over here? We don't want that. You can actually superimpose your parabola on there. Questions on your domain restrictions? Those were the three we've been using all year. Okay, let's jump up to this last graph. Because we did this kind of a while ago. Number 15. Is number 12? Okay, number 12. Really? Same exact one? Okay. Okay, so number 12. We're going to graph this guy. So it says sketch. So let's pull in a sketch first. We're going to say negative x cubed square x. We're going to graph it. Just do a zoom 6. Give me a normal graph. Now, we know from the past, 3, the highest exponent, tells us how many roots we have, how many zeros, how many times where does it cross, if it's a real, if it has real roots or if it has imaginary roots. We know 3 minus 1, these will tell us 2 turning points. We see it turn twice, 2 minus 1, 1 inflection point. We're going to add the inflection point to this. And we're going to add concavity. Okay, so we've got kind of a sketch going on here. We know what the sketch looks like. Make sure you sketch if it says sketch. And make sure it looks reasonable. Now, from the sketch, can you tell me what the domain is? Negative infinity to positive infinity. There's not one x value that I can't use. What's the range? Same thing. All real numbers. Good. Now, when we did this, we had maximums and minimums. We had absolute maximums and minimums. We had relative maximums and minimums. So what would you say this point A is? Good. It's a relative max. An absolute max would just be like where a parabola turns. It's absolutely the highest point. This is relative to that area. And B, therefore, would be my relative min. We find these on the calculator 3 decimal points. So we go to your calc, we do second trace, we come to maximum. Easiest way is just run that little flasher where it says left bound, keep it to the left of that maximum point. Where it says right bound, just move him until he's just to the right of it. Now it's going to search between those arrows. Make sure you go to 3 decimal places. Remember, I'm not grading these, so it's not as lenient over here. Okay, now we're going to do the same thing with your min. Second trace, we're going to do a min. We're going to bring it to the left of that minimum point. Then we're going to bring it to the right of that minimum point. Then we're going to guess. We're going to get there as well. 3 decimal places. Now, to find your inflection point, we're going to have 2 turns, 1 inflection. It's where I've changed my mind. My concavity said I was caving up here, but then I caved down here, so halfway through, I changed my mind. So it's the average of the x's. Average of my relative max x and my relative min x. So I'm going to take them. I can see clearly where it is, but I still have to show it algebraically. And x is equal to 0. Now, it won't always be 0. Once you find it, go back to your table, second calc, and do a value, put in your x value, and find your y value. Even if you can clearly see that this has symmetry, do it anyway. So your point is 0, 0. This is where your concavity goes. Your concavity goes to this inflection point. We'll call that C. So I'm concaving up. Remember, we trace your x values from negative infinity to 0. Then I'm concaving down. Then I concave down from 0 to infinity. I'm following my x values, not my y values. Good?
For the concavity, it's the x that you use?
Mm-hmm. I'm watching the y slope up for a concave up. I'm watching the y come down for a concave down, but I'm telling you what intervals are by the x value. I said if you look at x from negative infinity to 0, you're going to see your y concave up. If you look at x from 0 to infinity, you're going to see your y concave down. Increasing, decreasing, these go off your max and your mins. And also, they are x values. It's like a roller coaster. I'm coming down, 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 down. I'm decreasing from negative infinity to that x value. Then from this x value to this x value, I'm on my roller coaster, increasing. Then I'm at this point on my roller coaster, decreasing. Good? Now all I have left to do are my intercepts. And you have to solve your intercepts algebraically. I know you can see where they are. I know you can find them in the calc on this guy, but you have to find them algebraically. So to find your y-intercept, we're going to set your x equal to 0. Come back to your equation, and you need to show me the substitution. I can clearly see it's at the 0, but you need to show this to me algebraically. Then I'm going to solve my x-intercept. Set y equal to 0. This is going to force me to factor this guy. So what do both terms have in common? So if it's easier, take out the negative x to leave your first term positive. So it's going to be x squared minus 4. Confirm these on your calculator. So x is equal to 0. You can add to the other side. You can do your two perfect squares, whatever you like to do. Or add it to the other side. Remember, if you take the square root, get a positive and negative. X is 2, x is negative 2. So I know all my intercepts. I know everything there is to know about the square. Remember doing these?